Alright, we'll talk about them in a second. Triangle proofs and CPCTC. The CPCTC is the part I mentioned to y'all when we first started this stuff. It's in your notes a couple different times. If anybody got those notes available, you should be able to tell me what CPCTC stands for. Thank you. Corresponding parts of congruent triangles are congruent. So it's a CPCTC. It's a reason we're going to use in our proofs. We can only make this, use this reason with the statement after we prove triangle congruent to a triangle. So it says use when asked to prove parts are congruent. But first, you must prove the triangles are congruent. So what y'all been doing this whole time for me since Thursday is proving a triangle congruent to a triangle. For example, this is Isaiah's. You turn this in. If you look at all the proofs y'all did, it was saying prove triangle congruent to a triangle. Prove a triangle congruent to a triangle. Prove a triangle congruent to a triangle. That's all the proofs you've been doing so far. The ones we're doing today, you're taking that extra step. After you prove a triangle congruent to a triangle, then you can say corresponding parts are congruent. This is CPCTC. Corresponding parts of congruent triangles are congruent. So if I call a triangle congruent to a triangle, then I can talk about the corresponding parts. For example, on this first one here, we first need to prove these two triangles congruent, which they call them ABC and ADC. So triangle ABC, we need to prove that congruent to ADC by what we've already been learning. But if you look, that line is line 4 in this proof. This line on this proof is where we're going to put our postulate or our theorem, either the SSS, SAS, ASA, AAS, or HL, based on how we prove the triangles congruent. But after that, once we prove the triangles congruent, we need to take the step further. They want us to prove that BCA is congruent to DCA, those two angles. If we prove the two triangles congruent, then any corresponding parts on this triangle could be congruent to each other. For example, once I prove the triangles congruent by some kind of theorem or postulate, then I can say anything else. I can say AD is congruent to, well, they already tell us that. I can say angle BAC is congruent to angle DAC. I can talk about angle ABC, this one up here, being congruent to angle ADC, or so on, based on me proving the two triangles congruent. Alright, and then I can make CPCT statements after that. That's all. That's the only additional piece we add in, the CPCTC. Everything else should feel very familiar to y'all today, if you've been doing your work. So start with the given. Once again, I'm showing you how to go through and do this, but some of y'all not doing it. I'm going around looking at y'all papers. Y'all got all this stuff down here filled out, but your figure is not marked. I don't know how that's possible. I know you either got it wrong or you copied it. I told you, that's the first thing I look at when I grade y'all problems on the proofs. I'm looking at this first, your diagram. Is it marked up? If it ain't, then I don't even worry about grading none of this down here, because I know this is all bull crap. There ain't no way you can get through all down here if you ain't got this marked up correctly. So I don't even look at it. Number one, given. AB is congruent to AD. I'm marking that. AB, side AB is congruent to side AD. Some of y'all still can't figure out the difference between a side and an angle. Y'all need to situate that for yourself. Then it says BC is congruent to DC. You can mark those congruent as well. BC is congruent to DC. And I've been doing this the whole time, but some of y'all still not doing it. You should see that when I mark another set of congruent sides, I use a different number of markings. The first one I use one marking and one marking. The second one I'm using 2 and 2. I'm sitting looking at some of y'all where everything is 1, 1, 1, 1, 1 all the way around. How do I know the difference between sides if I'm looking at it like that? Y'all need to mark them correctly. I've been showing y'all this since day one. Stop trying to do your own thing and do my thing. All that is given information. Then after that, they say proves angle BCA is congruent to angle DCA. Statements. AB is congruent to AD. Faith, how you know that? Given. Chris, second line. Reason says given. What's up? Alright. Juan, third line says reflexive property. AC is congruent to AC. We wrote that in ourselves. We need to mark that. The other stuff was given already, so we already marked it. We need to mark AC congruent to AC. Okay, after we mark correctly, we should, oh, you see how you're able to read that now, Reese? Now that we've marked it. What was it? Oh, you see how that works now. That's why I want you to mark it first. It should be easy to see your congruency once you mark it. Now, that's what y'all been doing on the work for me already. The additional piece is this. So now we prove the triangles to be congruent to each other. Now we can talk about corresponding parts on the triangle. Any corresponding parts they name after we prove the triangles congruent, we can just use CPCTC for that. Because once you prove the triangles congruent, anything that's corresponding that goes together on both triangles, then you could just use CPCTC as that reason. So they say angle BCA, and I'm going to just show you the angles. Angle BCA is congruent to angle DCA. BCA is congruent to DCA. That's these two angles right here I marked in red for you. Yeah, I know that now, and I know they're congruent because CPCTC. Corresponding parts on congruent triangles are congruent. Can't make that statement unless you prove the triangles congruent first, though. Or unless they tell you the triangles are congruent. Either way. Sliding on. That's the only thing additional is just that. Most of this y'all can already do on your own. Isaiah, start me out on number 2. It's a paragraph proof, but we start when I given information up top. So how am I marking that? With the what now? I'm marking a line on the sides. Arrows, thank you. Don't get we're not saying these congruent, we're only saying they're parallel. PS is parallel to QR. Can you stop with that, man? And worried about a fruit snack. Let's get this right. PS is parallel to QR. What's the other piece of given information? Thank you. Angle QPS is congruent to angle SRQ. A lot of y'all still having trouble right here, and I knew you would, but I've been preaching it since day one. How to mark an angle. Y'all don't even know what the angles are, and I don't know what to tell you about that. The letters are helping guide you there. QPS is drawing the angle for you. QPS. The angle is right here in the middle on P. SRQ. 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 I'm going to do it 3 times for those kids. SRQ. Middle letter is where the angle is actually formed. It's not something out of bounds I'm asking y'all to do. I got kids still can't mark angles for me. You're going to struggle if you can't do that. After that, that is all my given information. They want me to prove that segment PQ is congruent to segment RS. So we're going to walk through this paragraph proof, excuse me. It starts out, it says, it is given that angle QPS is congruent to angle SRQ. That's what we just marked just now. These 2 angles is congruent. And then it says, since it is blank that PS is parallel to QR. Isaiah, you know what should go there? F, right? Given. They told us that they were parallel. F there for given. We can say angle PQS is congruent to angle RSQ by blank parallel lines. Before you decide that, you need to go in here and mark those 2 angles as congruent to each other, because we haven't marked these angles yet. PQS is congruent to RSQ. You need to mark those 2 angles as congruent. You need to be able to find them. I can't show you every time. I'm not going to be sitting there with you on the test pointing out where your angles are. You need to figure that out for yourself. I can't ask you right now because it's too specific. But PQS, follow the letters. PQS. Middle letter is where the angle is being formed at. Q right here on this side of the figure. This is the angle I want. But I'm going to mark that with 2 markings. I'm distinguishing it from my first angles that I marked. They are not the same. PQS is congruent to RSQ. If you mark them correctly, you'll see what they're trying to show you. So it's saying PQS is congruent to RSQ. If that is the case, on this next line it says we can say that PQS is congruent to RSQ by a blank of parallel lines. Who said that? Jamal, thank you. He said A, definition of alternate interior angles. These are alternate interior angles. Y'all should notice that by now. I don't know how many times I got to show it to you before it clicks in your mind. Next thing, we also know blank by the reflexive property. Dior, give me this one. We also know blank by the reflexive property. You said QS is congruent to QSJ. Amani, explain to us why that is wrong. He said J, QS is congruent to QS. No, you said that backwards. Exactly. This is a rotation. This is not a reflection. So which one should be correct? G. QS is congruent to SQ. If somebody needs help with that, I've already explained that to you once or twice, but I'll do it one more time. Why not? If I were to name these triangles, say I will call one of them PQS. The first one PQS. I will have to call the second one RSQ. If that's the case, PQS, the QS part goes with the SQ on the second triangle. Anyway, this is a rotation, not a flip. So when you name this reflexive property, it should be QS is congruent to SQ. Alright, so in the next line, it says due to the blank congruence postulate. Oh, first I messed up. I didn't mark something and did what y'all do. We just named reflexive property. We should show that on here. QS is congruent to SQ. You should show that on your figure. Now the line after that says due to the blank congruence postulate. So it's asking for the congruency. Now how do we know these are congruent? You should be able to read and see that. Juan, you got my answer? What's up? AAS, yes. So on this one, it should be C. Due to angle side congruency postulate, we can state that. And then here they just writing it backwards. This is that line where you're telling the congruency postulate and the name of the triangles. So you got to pick the right name. Say we can state that blank is. Which one? Let's look at I. I says triangle SQP. It's congruent to triangle RQS. It's which one? It's D. It says triangle QRS is congruent to triangle SPQ. That is named correctly. We can use D. And then, so this is the very last line of our proof. It's just in paragraph form. Since we know blank, we can conclude that PQ is congruent to RS, what we were trying to prove anyway. So what's the blank here? Can't hear you. Sophia, okay. Yeah. H, thank you. CPCTC. Y'all handle the two on the back. Come around and make sure you're right. Once you handle those, you can slide to the Math Excel. It's only 10 questions. Like I said, it shouldn't take you that long to do that either. And then after that, you can finish your work you decided not to do over the weekend.